All right, here we go. The next law is going to be called linear pair postulate. So those of you who have been here since the beginning, remember linear pairs? Two angles that are a linear pair, it's actually called a postulate. And remember at the top of your paper, a postulate is something that's assumed to be true. Linear pair postulate. It's a truth that's assumed to be true because it's so obvious. Go to write linear pair postulate. And here's what it says. Linear pairs are supplementary. Chang, you remember what supplementary means? They equal 180 degrees. So linear pairs are supplementary. It's that straightforward and that obvious. It's just bam, here's a truth. It's a postulate. Linear pairs are supplementary. Let me draw a picture of linear pairs. Franco, Rivera, and Chang, you should remember this. Here's angle 1 and angle 2. And they're right next to each other, they equal 180. So I'm going to write measure of angle 1 plus the measure of angle 2 equals 180. So I'm giving you an example for this postulate. I'm giving you an example that we'll put right in that box. Yes? What thing? All the 5 branches? I'll give you one later. Got you. I'll give you another one. So linear pair postulate. So far, so good. Right, Rivera? I'll give you the extra one? What's the matter with me? So linear pair postulate, linear pairs are supplementary. There you go. You got it. I'm going to write that in there. And you'll just transfer that to the other one when you bring it tomorrow. All right, next one. Ready, Rodriguez? Vertical angles theorem. Well, the first one's linear pair postulate, right? Next one's vertical angles theorem. What's the difference between a postulate and a theorem? It's on top of your law book. What does it say? I'll give you an extra stamp if you can give me the difference between a postulate and a theorem. Yeah, what's the difference? Like in one word. And what about a theorem? It's proven. So a theorem is proven, a postulate is assumed. They're both truths. One's assumed, one is proven. So what I'm about to write right now has been proven by argumentation. Postulates are not proven, they're assumed to be true because it's so dang obvious. And here's what the vertical angles theorem says. Vertical angles are what? Veteran students, remember for an extra stamp? Vertical angles are always what? Thank you. They're congruent. Lines are parallel, not angles. Careful. And let me draw a little picture again for this one. Okay, when 2 lines intersect, remember that? I'll say 1 and 2, so I'm going to put angle 1 is congruent to angle 2. We know that already. Now we're just writing it in our law book because we're going to use that for some argumentation shortly. But this is something we know already. Vertical angles are congruent. Now you know that it's a theorem. It's been proven. Okay. Last one's going to be a postulate. For today, at least. You're only doing 3. All right, last one. Ready, Chang? Come on. Corresponding angles postulate. Sorry, this program is not letting me put the G on corresponding. Should be an ing, but something's up with this program. There. Corresponding angles postulate. Yeah, it's right there, but it's not letting me put it there. Thank you, Franco. There, I'm crossing that out for Mr. Franco, all you YouTube listeners. This is all going to be on YouTube. Franco's calling Munguia out in front of everybody. All right. All right, here's what corresponding angles postulate says. So watch this. Postulates, remember, are assumed. This truth I'm about to write down assumes, this is all an assumption, but it's pretty obvious. Watch. If two lines, if two parallel lines are cut by a transversal, remember that we did that a couple weeks ago, veteran students in here? If two parallel lines are cut by a transversal, then corresponding angles are congruent. Try to write small because you're going to put a little picture in here. Then corresponding angles are congruent. We draw two lines that are parallel, cut by transversal. Then put 1 and 2 right here. Look at measure of angle 1 is equal to, I'm just going to write 1 is congruent to 2 actually. Angle 1 is congruent to angle 2. So I drew a little picture for all three of these today. Typically we haven't been drawing pictures, but for these three I want a picture there for reference purposes for you guys. I will do one example and we're done. You go on your grade check and credit check. So this one example you can put on the back of your law book or on a separate sheet of paper. I can care less. You guys are young men now. You guys organize your notes the way you see fit. Here we go. I'm not trying to baby you guys. You've seen some of this in summer school with me. Or last year sometime when we did parallel lines cut by in different angles. You've seen it before. Should ring a bell to some degree. I mean, you're not totally ice cold in the dark here, right? Here we go. Don't worry if you're behind. I got some stuff to catch you up. All right, here we go. One example, Rivera, watch. Go and draw two parallel lines. Chang, stay with me so I can get that stamp. Look, I'm putting little arrows. Remember, that indicates that they're parallel. The two lines are parallel. And I'm going to cut them with a transversal. I got two parallel lines cut by transversal. This is example 1 today, by the way. Forgive me. Again, put this in the back of your note guide, your law book, or a different sheet of paper. Say this is angle 1. Let's say this is angle 2. And let's say this is angle let's see here. Vertical. Yeah, 3. All right. So given, we're going to do a 2-column proof here. Given, let's call this line A and line B. A is parallel to line B. Right, the double bars mean parallel. And I want us to prove, watch this now, I want us to prove that angle 1 is congruent to angle 2. Or 3 rather. Make a statements and reasons. Statements, reasons. Actually, you know what? I have my own, I already have my statements and reasons gizmo here. Here we go. So I'm only doing this example, so give me statements and reasons. Have your law book ready, because I'm about to give extra stamps for those who help me fill in the blanks here. I'm not going to give an extra stamp, though, for the first line, because that's like, exactly. You always start off with your given. In this case, line A is parallel to line B. That's given. Remember the IQ that's needed for that? 2 points above plant. You can have an IQ lower than ducks. I'm talking about looks like a rose plant. IQ 2 points above a rose plant. You guys can do this. Just put the given. Statement 2. Watch this. I'm going to provide the statements. Whoever can tell me the reason first gets an extra stamp, but you only get one guess. My encouragement to you is not guess, but look at your law book. Watch this. Look at the statement I'm going to give you. Hang tight. Angle 1 is congruent to angle 2. Look at that picture and tell me what gives me the right to say that. Get it. What's up? After this period. Please. Okay? Angle 1 is congruent to angle 2. What gives me the right to say that? Extra stamp right now. That's when something's equal to itself. Watch the language. It's YouTube, man. Don't worry, YouTube fans. I'm going to take away Rodriguez's stamp for saying that. Just kidding. Someone give me a reason. Why is 1 congruent to 2? Good try. You only get one chance. Hit it, Rivetta.
Easy.
So Franco, Chang, or Rivetta, you guys can earn a stamp. Give me the reason. Look at the picture and try and figure out what law it's on our law book that allows me to say 1 is congruent to 2. I like that, but reflexive when something's congruent to itself. 1 and 2 are 2 different angles. So we're not saying something's congruent to itself. I'll give you a hint, but if I give you the hint, you can't have the stamp. That's when something's equal to something else and something else. It's like a chain. There's no chain yet. We will use that one though.
The beginning one's on the first page.
Good try. It's actually the ones we just did.
Oh, for those? Like, oh wow, corresponding.
Good try.
Oh, it's in your pair.
Good try. It's vertical angles. Here, let's see. Vertical angles. I'm going to abbreviate. Look at vertical angles. Was it a theorem or a postulate? It's a theorem. It's proven, yeah. And we can use that law in our argument. It's like a law that we can appeal to. Is 1 and 2, look at that. They're formed by 2 intersecting lines. Look at it. They're vertical. They're vertical angles. We drew a picture of them on your law book. All right, cool. How about step 3 now? Look what I'm going to say. Angle 2 is congruent to angle 3. What gives me the right to do that one? Why can I say 2 and 3 are congruent? Extra stamp. You get one chance, one crack at it. Postulate, huh? Prostate? Corresponding angles postulate. Very nice. I'm going to abbreviate corresponding. Just CORR, so I don't get a hand cramp. No computers right now, Rivera, right here. Your focus here, like a laser beam. Corresponding angles post for postulate. I got you. Another one too right here for the last step. Look at the last step. The last step would be what? What would I write for my last statement? I'll give you a hint. What do you always, what? What do you always write for your last statement? You always write given for your first statement. What is it you always write for your last statement? Well, you have to prove. Look at angle 1 is congruent to angle 3. Why though? What gives me the right to say this? Consult your law book. So, all you YouTube fans out there, my 5th period class almost got it. Chang got it, but he used up his first try. It is a transitive property.
I told you, yeah.
Go to my transitive prop of, I'm going to use the congruent symbol to abbreviate congruence. There it is. Notice, look at the chain argument. I'll highlight it, I'll color code it. Look at, let's let the green color represent angle 1. Let's let the red represent angle 2. Then look, I'll put red right here. And I'll put black to represent angle 3. Look at how the green and black are both congruent to the red. So I can say that the green and the black are congruent to each other. Green is red, red is black, so therefore green is black. See it that way. It's easier. All right, take a minute brain break, and then